As with all the other activities in the Quality Light Teaching Kit, the energy activity is meant to be done in a classroom setting, although it can be done in a science club or after-school event. In a classroom setting, the teacher will be the mayor, and the students will be divided into 6 different task groups corresponding to the different categories here. The students will start here by looking at the energy issues presented to the mayor. To understand these issues, the students need background on the energy. That's what this poster is for. This gives 3 different things on energy waste, cost, and carbon footprint, which are the problems presented by energy and light pollution. Down here are 2 different ways that these problems can be solved, through efficient bulbs and shielding. Once the students read through this poster and understand the background information needed, they can move on to the activity underneath. Now try this. If students want to continue to learn about energy, they can look down at the key ideas and go online and research these 4 different key phrases. When you get your Quality Light Teaching Kit, everything will be laid out in an easy to read manner. What we're looking at today is the energy activity. You just need the packet for the energy activity, as well as 3 different posters. Issues raised by citizens, light pollution and energy, and the energy calculations map, which looks something like this. In the energy packet, you will have several different items. A grid of the map of Houston, energy calculation worksheet if you do not prefer the map, the types of lights, and a start here, which will be used later. You also have 2 wet erase markers. This activity is designed so that in 3 different parts. The first part will involve the map of Houston. The second part will involve all the calculations, and as well as the third part. In the first section of the activity, you will be using the map of Houston with a grid superimposed onto it. Each grid box is 3 by 3 kilometers. In each of the boxes, it might possibly have a different color light, whether it is brown, white, or yellow. These 3 different types of colors correspond to different types of light. The brown being the low pressure sodium, the white being the metal halides, and the yellow being the high pressure sodium. Each of these bulbs has a different corresponding wattage to it, which will be used in the next section. To do this activity, have the students go through each row and count only the predominant color of lights that are in this. For example, in this one over here, the predominant color is white, so this would count as a white square. However, next to it is predominantly brown, so that would be counted as a brown square. Do not have the students double count squares, as this will throw off calculations. Also make sure that the students do not count the black squares. If you do not wish to have the students count the squares, the number of each color of square will be provided in the next section. Once the students have finished counting up their types of bulbs with white light bulbs here, yellow light bulbs here, and brown light bulbs here, we can move on to the calculations. In the bulb type 1 box, we can start by finding the efficiency of bulb 1. In the first box, put the number of lumens in from the corresponding bulb.
In this case, it's 22,000. Then put the wattage of the bulb. In this case, it's 250. This gives an efficiency of 88 lumens per watt. Now, using the boxes from over here that says 58, put the number of bulbs that correspond to that color. In the blue box, fill in from the blue box over here the total number of squares, which is 832. This gives the percentage of bulbs that are of bulb type 1 in the city. Now, take this number and put it in here to find the total number of bulbs in the city. This gives 140,000. In this box, take the wattage from over here in bulb type 1 and plug it in. This will give the energy used in one night by one bulb of type 1. Take this number and put it up here. Now, divide by 1,000 to give the kilowatt hours used in one night by one bulb. Once you've found this number, plug it into these three spaces right here. Now, multiplying by the cost of the kilowatt hour, we find the total cost to run one light bulb of bulb type 1. In this box, this gives the total amount of greenhouse gas that's produced by one night of one bulb. Up here, plug in the total number of bulbs that you found from step 3. In this box, take the cost to run one bulb and plug it in. Now, multiplying this will give us the total number of watts used by all the bulbs of bulb type 1. This will give us the total cost to run those bulbs. In this box here, take the corresponding color from step 7 and plug it in. Again, put the total number of bulbs to find the total amount of CO2 produced. In this box, take the corresponding number from step 8 and plug it in. This gives the total amount of wattage that's wasted on lights that are unshielded. In this box, take the corresponding number from step 9 and plug it in. This gives the total amount of cost that's wasted. From step 10, take the final number and plug it in down here. This gives the total amount of CO2, excess CO2 that's produced by running these bulbs. Now, take these final numbers and plug them in over here in the corresponding colors. After adding these up, this is your grand total of the amount of carbon, cost, and energy wasted on unshielded lights. You will now do the same thing for bulb type 2 and type 3, again using the corresponding values from the Start Here box. Once you've found the numbers in the last 3 boxes, step 11, 12, and 13, take those numbers and plug them into each of the different types of bulbs. Total them up, and that's the total amount of energy, cost, and CO2 that is wasted on uplight. Uplight is the light that is lost into space and never used on the ground. That is what you calculated when you multiplied each of these values by 30%.
In section 3 of the energy activity, the students are going to try to minimize the amount of energy wasted, cost wasted, and their carbon footprint by changing the lights. In the energy envelope, you will find a types of light handout. In this types of light handout has all of the bulbs from the previous section, such as the metal halides, high pressure sodium, low pressure sodium. On the back side is the lights that we recommend as being the most efficient. In the energy envelope, you will also find a Start Here. Put this over the Start Here as there have been modifications to the poster. Carry out the calculations in the same way using the different bulb types and possibly different numbers of hours per night. Once these 3 calculations have been done, plug in each of the values for the energy wasted, cost wasted, and carbon footprint from the 3 types of bulbs. Take these numbers and put them on the second line corresponding to the colors. Blue to blue, red to red, and green to green. Now, from the previous side of the poster, take the old values that you had in these squares. Put them here and subtract to get the total amount saved by switching light bulbs. Now that the students have finished calculating the savings in energy, cost, and carbon footprint, they can now choose the format in which to present to the teacher and the rest of the class their findings and suggest possible next steps.